All right, guys, so we're going to take a look at some examples working with partial circles. There was a couple assignments that dealt with partial circumference and partial areas of circles. We'll take a look at 4 examples of each, and hopefully this will help you out. The first one we're going to look at is arc length or partial circumference. And remember, the circumference formula is 2 times the radius times pi. Okay, so that's what we're going to start with. So we have the example. We have a semicircle which has a radius of 11. Okay, we're not going to necessarily worry about the fact that it's a semicircle right now. What we're going to do is we're actually going to calculate the entire circle. So as if this was a full circle. Okay, so calculating the circumference of a full circle, we use this formula here. So circumference equals 2 radius times pi. Our radius is 11. So first step, we'll just substitute into our formula the radius. Simplify it down a little bit further. Okay, and we have the circumference of the entire circle. Now notice I left it in terms of pi. This is absolutely an acceptable way to put your answer in. You can leave pi as essentially this variable. Okay, this variable symbol here represents 3.14 about. So we can leave it as pi. That's what I'm going to do. But again, we have a semicircle. So we don't want the circumference of the entire thing. We only want half of it. So at this step, you're going to figure out what percent or what fraction of the entire circle you have and multiply it by that number. Okay? You gotta hang on, Taylor, buddy.
Okay.
Oh, jeez. All right, so since this is a semicircle, we have 22 pi. We're going to multiply it by 1/2. Okay, 22 times 1/2 is the same thing as 22 divided by 2. So the circumference of the arc is 11 pi. And that is your final answer. If you plug it in just like this, it's going to be correct. All right, that's the first example. All right, the next example that we have here is a little bit different. They don't give us the radius. They give us the diameter of this circle. Okay, not too hard to work with. Just remember with the circumference formula, we do need radius. And remember, radius is half of the diameter. So if we take the diameter and divide it by 2, that'll give us the radius. So the radius in this case, just plug it in real quick right here, equals the diameter, which is 12, divided by 2, or 6. Okay, so that's what we're going to use in our formula for the arc length. Okay, so again, we're going to consider the entire circle. We're just going to calculate it as if we were trying to find the circumference of the entire circle. We'll deal with the fact that it's actually a semicircle later on, but let's calculate the entire circumference. So plugging into our formula, we get circumference is equal to 2 times the radius, which we calculated was 6, times pi. Circumference, again, of the entire circle is 12 pi. So now what we want to do is we want to actually consider the fact that this is not a full circle, it's only half a circle. So once we get to this step, we're going to take this number and multiply it by the fraction of the circle that we have. In this case, 1/2. 12 times 1/2, or 12 divided by 2, gives us 6. So the circumference of the arc, or the distance of the arc, is 6 pi. Plug that answer in, and you will be all set. All right, and this third example here looks a little bit different, but the process is essentially the same. So again, what we're going to do is we're going to look at the arc length, this arc length here, by calculating the partial circumference. So again, what I want you to think about is the entire circle that this arc length makes up, and let's calculate the circumference of the entire circle. Okay, we'll deal with the fact that it's actually a quarter of a circle later on. So calculating circumference, remember circumference is 2 times the radius times pi. So circumference is equal to 2 times the radius, which in this case is 1, times pi. So the circumference of the entire circle is 2 pi. Okay, but we don't want the distance of the entire circle. We only want the distance of the arc, or the 1/4 or the quarter of the circumference. So once we get to that step, we're going to take this number here and multiply it by 1/4. Multiplying 2 by 1/4, okay, 2 over 4 simplifies down to 1/2. So the circumference here is 1/2 pi, or 0.5 pi. And again, plugging both of these answers in, leaving it in terms of pi would be correct. For our last example, again, it looks a little bit different, but again, the process is very similar. So what we have here is we have a 3/4 circle, or a 3/4 arc that we're trying to calculate. Okay, and what I want you to do is think about it as a full circle, and let's calculate the circumference first. Okay, so again, the circumference formula: circumference equals 2 times the radius times pi. Circumference equals 2 times the radius, which in this case is 5, times pi. Circumference equals 10 pi. Okay, now that's the circumference of the entire circle. We don't want the entire circle. We are only considering 3/4 of it. So when you get to this step, what you're going to do is you're going to take this number and you're going to multiply it by the fraction of the circle that we have. In this case, 3/4 or 3/4. Multiplying 10 by 3/4. Okay, if you multiply whole numbers by fractions, if you remember, you can take 10 over 1 times 3 over 4. Cross simplify, and you get 15 halves. You can take that answer, that will absolutely be acceptable, 15 halves pi, but you could also simplify 15 halves a little bit further, or change it to a mixed number. 7 1/2 pi would work, or 7.5 pi. All acceptable answers. Again, I left them all in terms of pi. That is absolutely acceptable. Leave pi as a variable. Since pi is an irrational number, this is actually a more exact answer, rather than changing it to 3.14 to get an approximation. So plug that in as your answer, and you'll be good to go.